Hello, everyone. Today we're going to be solving this equation here, differential equation using the Laplace method. The equation goes as follows: y double prime plus 16y equals u of t minus delta of t minus 1. The given variables is y of 0 equals 0, and y prime of 0 is equal to 1. Step 1, we're just going to do the Laplace rule on this equation. Now, we got this right here, the y double prime, and that's going to be s squared y of s minus s times the given variable of y of 0, which is 0, so that's just going to cancel out, make it 0, minus the given variable of y prime of 0, which is 1. Then we just go ahead and jump over to our next variable, which is 16y, which is going to be 16y of s. It is equal to the Laplace on the right-hand side will be as follows. So we got u of t, it's a unit step heavy side function. So it's going to be e to the negative as all over s. A is 0, so that's just going to make e of that just 1. So it's going to be 1 over s minus delta, which is e to the negative s. We'll keep on going here. So then I'm just going to make it look pretty. Start separating some variables. I got everything of y of s on this side, and I put the 1 over here. And we got y of s by itself, and now we got our first clause done, which is going to be y of s equal to 1 over s times s squared plus 16 minus e of negative s over s squared plus 16 plus 1 s squared plus 16. Now, step 2, this is just making it look pretty. This is going to be separating that first bit right here, make it in 2 equations because it's very hard to do the following steps if we don't. So I'll do that. This right here is pretty simple, nice and easy. I'm just going ahead and skip down to what I got. That's going to be this right here. And that's going to be 1 over 16 times 1 over s minus 1 over 16 times s over s squared plus 16. And that right there, there's amazing steps for us. It's going to make it look much nicer in a bit later on. So then I went ahead and just switch things around. So step 3 can actually be done. So we got 1 over 16 times 1 over s minus 1 over 16 times s over s squared plus 4 squared, and minus 1 over 4 times e to the negative s times 4 over s squared plus 4 squared plus 1 over 4 times 4 over s squared plus 4 squared. And if you notice, I added 1 over 4 over a couple of things. When doing the inverse Laplace for step 3, which we're about to begin, makes it a lot easier. About to find out. So inverse Laplace for this one, 1 over s is just 1. So you just got 1 over 16 minus the next part, 1 over 16, let's put that in front, times, so that's s over s squared plus a squared, which is 4. And that's going to be cosine. So then we got cosine of 4 over t minus, this is why I did the times 4, because if you put a 4 on top, we can just make that into the sine, and it's a whole lot easier. And since this is e to the negative s, that's going to be the unit step. So we got 1 over 4 unit step t minus 1 times sine 4 times t minus 1. And this is the same thing as the one prior without the unit step. So it's just 1 over 4 times sine 4t. And that's our y of t right there. Same thing, I just rewrote it, make it look prettier. Then our final thing is the same, but prettier. So anything that is less than 1 is just pretty much everything without the unit step. Anything greater than 1 is the same thing, but the later half of the unit step equation. And right there, that's pretty much how you solve the differential equation using the Laplace method. Thank you. Appreciate your time.